Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit, and today we will discuss one of the important component that is used in the preparation of the electronic gadgets. So the today's topic is the field effect transistor that is used for basically the use in the circuit design. They are able to provide very much high input impedance and levels along with the significant level of the voltage gain. So field effect transistors are used in circuit designing as they are able to provide the high input impedance along with the significant level of the voltage gain. Unlike the bipolar transistor, which is a current control device that we have already discussed, the field effect transistor is a voltage controlled device. Bipolar transistor is a current control device, but field effect transistors is a voltage control device. So this makes the way FET, that is the field effect transistor, that is FET circuit, are designed rather different to the way bipolar transistor circuit, and its design is different from that of the bipolar circuit transistors. So circuits with current and the voltage gain can still be designed, and similar circuit formats that we adopt in the preparation of the FET. Now first we will discuss the introduction about the FET, then how we prepare how they are designed, moreover how they work. After that, types of FET we will discuss further in this lecture. So what is FET? FET means field effect transistor. Basically it is a 3-terminal device, that is the active electronic device, and that is made from the semiconductor material. So it is a 3-terminal active semiconductor device in which an electric field produced by the input voltage regulates the output current. It is a active semiconductor devices where an electric field produced by the input voltage regulates the output current. It means when we regulate the voltage, then it gives the output current, because unlike bipolar transistor, FETs only either used electrons or holes as a charge carriers, and they are also refers to as the unipolar transistor. Field effect transistors are also referred as a unipolar transistor because they FET only use either electrons or holes as a charge carrier. So apart in spite of the bipolar, which are different from that of the FET. Now the field effect transistor is a voltage operated device because it uses the voltage applied to its input terminal. Means when we apply the voltage, then we get the current as a output. So voltage operated devices, because as we use the voltage and it is applied to as an internal terminal, that internal terminal is the gate. It means we apply the gate to the that is the input terminal. We apply the voltage to the gate, which is the input terminal, to control the current flowing from the source to the drain. It means here we are having a gate, source and drain. So due to its small size and significant lower power consumption, FET are widely used in the integrated circuit. Many type of electronic ICs use the FET. In addition, FET are utilized in the logic circuit preparation, operational amplifiers, tone controls, high power switching applications. We use the we use the FET, and voltage variable resistors in which we can use the FET, tone control, and there are the many electronic components where we use the FETs. So because of its small size, and that will be used in the integrated circuit. What are the basic circuit of the FET? When we consider the use of FET in a circuit, it is necessary to consider the FET technology, and the type of field effect transistor will be the most applicable in this series. So FET having the 3 electrodes. What are they? First is the source electrode. The source is the electrode on the FET through which the majority carriers enter the channel. Majority carriers means where we are taking the electrons or holes, it depends. So source is the electrode on the FET through which the majority carriers enter the channel, that is, it acts as the source of carriers for the devices. Source act as the carrier of the devices. Current entering the channel through the source is designated as IS. Second is the drain. Drain is the FET electrode through which the majority carriers leave the channel. Through source it enter in the channel, but through the drain the majority carriers left out from the devices, electrodes. So they are drained from the channel. That's why it is a drain. Source where we put the majority carriers, drain where it is leave the channel. So drain is a FET electrode through which the majority carriers leave the channel, and they are drained from the channel. Conventional current entering the channel via the drain is designated by the letter ID. If we represent the current, then it is represented by ID. Also, drain to source voltage is often designated as VDS. If we talk about the source as the current entering in the source, that is represented by the IS. When it is left out from the drain, then it is represented by ID. When it is moving also from drain to source voltage, that is designated as the VDS. Third electrode is the gate. Gate is the terminal that control the channel conductivity. Hence, the level of voltage of the gate controls the current flowing in the output of the devices. Gate is the terminal that controls the channel conductivity. So, the level of voltage on the gate control the current flowing in the output of the devices, that will fix it. Now, you see on the screen that this is a one type of the transistor, that is FET, field effect transistor. You see on the left hand side we are having a source, right hand side we are having a drain, in between that we are having a gate, and body that is made of the semiconductor. Right hand side, these are the gadgets we use in the laboratories and in the electronic circuit as a FET. Now, the source, drain, gate and the body terminal or FET are its a 4 terminal. That is the, now you see that here we are having a source, gate, drain and the body. We can take the output from the body. So, terminal known as the source is where the majority of the carriers are introduced into the FET. Drain terminal where the majority of the carriers leave the FET. The gate terminal is created through the diffusion of an N-type and P-type semiconductor. On the basis of that, we define it as that it is an N-type of FET or the P-type of FET. As a result, the region of the PN junction that is heavily doped regulates the carrier's flow from the source to drain. So, it is maintained, the gate maintain the flow of carriers from source to drain. Then the substrate on the FET is constructed is called the body, on which the FET is constructed, that is the substrate, that is also known as the body. Since it is internally connected to the source pin in the discrete application, its effect can be completely degraded. However, because it will be shared by the several transistors in the integrated circuit, this pin will typically be connected to the most of the negative power supply in the circuit. So, we are having the positive negative power supply in the NMOS and positive in the PMOS, that will be discussed further. When the body connected is when body connection is involved, then the careful connections and the design are essential to maintain the FET performance. The semiconductor which we are using will increase the performance of FET. Moreover, the connection between the body and gate and the terminals, then it will enhance the performance of FET. The majority of carriers pass through the channel as they travel from the source terminal to the drain terminal. It may be positive or negative. So, we define it as the, now you see on the screen, this is the symbol for the N channel and the P channel, where you are seeing that this is the symbolic representation of FET. Left hand side we are having the P channel. You see that the here here the arrow is outside the towards the gate, but here in the N channel the arrow is opposite to the gate. So, you see that this is the symbolic representation of the P channel and N channel. P channel and N channel we define the majority carriers. Like if we talk about the N channel, then N channel FET has a channel made from the N type of semiconductor, in which the majority carriers are the electrons. But if we talk about the P channel, where the majority carriers are the holes, and that is why it is a P type semiconductor we will use for the construction of the P channel FET. So, the symbolically we represent the P channel and an N channel FET, and this is very where we are having a gate, source and drain. If the arrow outside towards the gate, then it is a P type, and if it is opposite to the gate, then it is a N type. Next is, there we can have a number of the parameters that require for the requirement for the transistor circuit design. There are some parameters which are used for the circuit design. Number one is the voltage gain. The voltage gain is often the key requirement, because the output signal voltage divided by the input signal voltage. How much input signal we are giving, on the basis of that we just require the voltage, and that is the voltage gain. Second parameter which is very important in the FET is the current gain, and this gain of the FET circuit in terms of the current, it may necessary to drive a high level of the current into the load. Next is the input impedance, that is also the one of the important parameter in the FET. This is the impedance that the previous stage will see when it is providing a signal to this FET circuit in the question, or FET inherently have a high input impedance to the gate. Therefore, FET are often used where this is of the paramount importance. What about the output impedance? The output impedance is also important, as if the FET circuit is driving a low impedance circuit, then its output must have a low impedance. So, output impedance will depend upon the input impedance. Otherwise, a large voltage drop will occur in the transistor output stage. So, when it is a low impedance circuit, then output must be the low impedance. Otherwise, a large voltage drop will occur in the transistor circuit. Next parameter which is also important is the frequency response. Just to check the frequency response is another important factor for the FET circuit design. If we use the low frequency or the audio transistor circuit design, may be different to those of the RF applications. The choice of FET and the capacitor value in the circuit design will greatly affect the required frequency response. So, frequency response is one of the key parameter in the FET. What type of frequency we use, low or high, as depend upon the required frequency response. Next is the supply voltage and the current. In the many circuit, the supply voltage is determined by what is available. Means current may be limited, especially if the finished FET circuit designed is to a battery powered. So, supply current and voltage is also important. Now, if we talk about the composition of the FET, how we construct the FET, what material we use for the preparation of the FET, as FET is used in the integrated circuit. So, FET can be constructed from the various semiconductors, like where we will use the silicon. By the far the most common material which is a semiconductor is the silicon. Most FET are made by using the conventional bulk semiconductor processing techniques, where we use a single crystal semiconductor wafer as the active region or as a channel. So, semiconductor will be used for the preparation of the FET. Among the most unusual body material are the amorphous silicon, that may be the polycrystalline silicon also, or the other amorphous semiconductor in the thin film transistor or the organic field effect transistor that is based on the organic semiconductor oftenly used for the preparation of the. And for the gate insulators and the electrodes are made of the organic material as well, that is OFET. When we use the organic material, then this FET is the OFET, that will be the organic field effect transistor, where we use the thin film of the organic material, organic semiconductors. Such FET are FET are manufactured using a variety of the material. What type of material which we can use? You see on the screen that the silicon carbide we can use, gallium arsenide we can use, that is GaAs, gallium nitride, and the indium gallium arsenide we use for the preparation of FET. Nowadays in the nano materials we use a quantum dot for the preparation of the FET. We also use the carbon nanotubes for the preparation of the FET. So, what material we can use? Silicon carbide, gallium arsenide, GaAs, gallium nitride, GaN, and the indium gallium arsenide. Now, if we talk about the FET history, then in June 2011, IBM announced that had successfully used the graphene based FETs in an integrated circuit. Means graphene as a material we can use for the FET preparation, and these transistors are capable of about the 2.3 gigahertz cutoff frequency, so which is much higher than the standard silicon FET. So, graphene is one of the best semiconductor material for the preparation of the FET, whose efficiency is more as compared to the other conventional semiconductors. Now, what are the characteristics of the FET? What are the main characteristics of the FET? As the FET field effect transistors have the several distinguishing characteristics. Here some we can define. First is a high input impedance. FET have a high input impedance where we talk about the resistance, often in the mega ohm range, and this makes them ideal for the use in many electronic devices and its application in many electronic devices where minimal loading of the signal source is desired. So, for the high input impedance, so we use the FET, where we use the minimal loading of the signal sources required. Second is characteristics is the voltage control. FET, the output current is controlled by the input voltage. So, this property is utilized in the amplifiers and the switching applications. So, we can control the voltage, then output current will be controlled, automatically. So for this power, this property is utilized in the amplifiers and the switching applications. Next characteristics is a low power consumption. FET, especially MOSFET, that is a one type of the FET having a low power consumption, so making them suitable for the use in the battery powered devices. The characteristics of the FET are primarily determined by their operating region also. So some of the four reasons that are the ohmic, saturation, cutoff and the breakdown. These are also the important characteristics of the FET. So we can define it as in the ohmic region, which is the region where the transconductance exhibit a linear response and the current at the terminal gate is opposed by the resistance. So in the saturation region, the device is fully on in this region and the maximum amount of the current flows through the transistor at the steady state during the this condition when we are in the saturation region. Third is the cutoff region, where during this region there is no current flowing through the transistor. As a result, it is referred to as a device in the off state. The fourth point is the breakdown region. Now, when the applied voltage exceeds the maximum value of the voltage, the transistor enters the breakdown condition and indicating that it resists the flow of current. In the breakdown region, it resists the flow of current. So here we are having the four on the basis of the operating region we can characterize the FET, ohmic region, saturation region, cutoff region and the breakdown region. So these are the basic characteristics of the FET. Now the characteristics on the designing, we are having the basic characteristics on the basis of the designing. As we know that if the majority carriers are the electrons, then we are having a n channel FET. When the majority carriers are the p type holes, then it is a p channel FET. So FET for use in the circuit design, characteristics on the basis of design are n channel, as the n channel FET has a channel made from the n type semiconductor in which the majority carriers are the electrons, and the p channel, a p channel FET has a channel made from the p type semiconductor in which the majority carriers are the holes. Next is the JFET. JFET means where the J for the junction. J for the junction FET is the form of FET where the gate is formed by using a diode junction into the channel. So the isolation is maintained by ensuring that the diode junction remains reverse biased when operated within the circuit. So isolation maintained in the JET, where the junction FET is a form of FET where the gate is formed by using a diode junction into the channel. So it is a key requirement of the FET circuit design to ensure the junction remains reverse biased for the satisfactory operation in the JFET. Next type of the FET is the MOSFET. This type of field effect transistor relies on the metal oxide later between the gate and the channel. So it offers a high input resistance. Next is the dual gate MOSFET. As the name implies, it forms a MOSFET has the two gates. FET circuit design, this gives the additional operation. Next is the enhancement mode. Enhancement mode FET are the off at 0 gate source voltage, and they are turned on by pulling the gate voltage in the direction of the drain voltage. that is towards the supply rail, which is positive for the N channel and negative for the P channel. In other words, if we take about the pulling the gate voltage towards the drain voltage, the number of the carriers of the active layer of the channel is enhanced. Thank you very much. We will continue this in the next lecture.